Salvation International Preparatory School. Salvation International Preparatory School. A place to be, a school to go. We'll build you up from the cradle to university. Salvation International Preparatory School. Salvation International Preparatory School. A place to be, a school to go. We'll build you up from the cradle to university.
Good afternoon, class. Good afternoon, ma'am. You're all welcome to today's class. I will be looking at basic science, and our topic for today is work, energy, and power. Now, work, energy, and power are common terms that we are familiar with in our daily activities. For example, if you are asked to fetch a bucket of water from the tap at your backyard and to take it to the kitchen. Now, before you are asked to do that, whoever is assigning that job to you already knows that you have the capacity to do it. So for the fact that you can do that job is why you be asked to do it, whether you've done it or not. So energy is defined as the ability or capacity to do work. Now, what is work? In literal terms, work is anything you spend energy on. Any productive activity that requires the use of energy is what we call work. But mathematically, work is defined as the product of force and the distance moved in the direction of the force. The product of force and the distance moved in the direction of the force. Now, in mathematics, product simply means multiplication. So mathematically, work is force times distance covered. So if you pick that bucket of water and you take it from the backyard to the kitchen, you've applied energy or force in moving that bucket, and you've covered a certain distance, meaning you have done work. Now, in every quantity in physics or in science, every quantity that is measured has what we call an international standard unit, or we call it the SI unit. Now, the SI unit for force is Newton, and the SI unit for distance is meter. And because we are multiplying force times distance, we multiply the SI unit, giving us Newton meter. So the SI unit for work done is simply what? Newton meter. Now, because you are consuming energy while doing work, the SI unit for work and the SI unit for energy are now the same, because for you to do work, you must possess energy. So it takes energy to do work, meaning the SI unit for both are the same. So the SI unit for energy is Newton meter, and the SI unit for work is Newton meter. Now, apart from Newton meter, another term is used called joules, and this is in honor of a scientist called James Prescott Joule. That's because he did much work in studying energy and work. Now, the last term we have here is power. Power is defined as the rate of doing work. If I'm to compare the time it takes you to take that bucket of water from the backyard to the kitchen with, let's say, 2 other individuals, the person that is able to do it fastest or more quickly is said to have more power. So power has to do with the rate, the time it takes for you to perform that particular task. So power mathematically is represented as work done over time taking. Again, the SI unit for power, from the formula work done over time taking, we already know that the SI unit for work done is Newton meters or joules, and the SI unit for time is seconds. So the SI unit for power becomes Newton meter per second or joules per second. quickly, we'll look at a calculation so we can apply the knowledge that we have just gained. The question here says, if a girl moves a block weighing 8 kg through a distance of 5 meters for 2 seconds, calculate her power. If a girl moves a block weighing 8 kg through a distance of 5 meters for 2 seconds, let's find her power. Now, firstly, we'll write out the quantities that we are given from the question. Number one, they gave us mass. The block weighs 8 kg. That makes mass 8 kg. And they said she moved the block through a distance of 5 meters. The time given is 2 seconds. And we are asked to find power. Power is unknown. Now, from the formula, we know that power is simply work done over time taken. But the quantities given to us, they didn't give us work done. So we have to calculate for work done. Work done is force times distance. Again, force was not given in the question, so we'll have to look for force. Force is mass times acceleration due to gravity. Now, because we are living in an environment, or in a gravitational environment, or in a gravitational field called Earth, everything that goes up is pulled down by a force called what? Gravity. And scientists have measured that for every object or body within Earth, the acceleration due to gravity is actually 10 meters per second square. And the mass given from the question is 8 kg. So that makes force 80 Newton. Remember, we talked about SI units. For every science calculation, what defines what you are talking about is the SI unit. So if you don't write the SI unit, it's assumed to be anything. But because we are calculating force, the SI unit for this is what? Newton. Now we'll proceed to calculate for work done. Work done becomes 80 Newton times the distance given is what?
5 meters.
Times 5 meters. 80 times 5 will give us 400 Newton meter or joules. Now that we have work done, we can now calculate for power. Power becomes work done over time taken. And from what we've calculated, our work done is what? 400 Newton meters or joules. The time given from the question is how many, please?
2 seconds.
So we'll simply divide 2 here 1, 2 here 200. So the power here becomes
200 Newton meter per second or joules per second.
Alright, so from this calculation, we see that the girl possesses a power of what? 200 Newton meter per second.
As a parent, I have always asked, how can I prepare my children for the infrastructural development and socio-economic evolution of the next decade? With the ongoing speed of globalization, how can I position my children to perform excellently in a rapidly changing society? The answer is and has always been to give them a solid foundation. Academically, spiritually, and morally. Salvation International Preparatory Schools, with her team of highly qualified tutors, conducive environment for learning, state-of-the-art computer and science laboratories coupled with quality day and boarding facilities is the place to be. For more information, contact 080-233-76135. SIPS remains the birthplace of leaders.
Alright, quickly we'll take a second example on our topic today. How much power does a student have who climbed a stairs of 20 steps and each is 50 centimeters high in 30 seconds? Now from the question, we are given the mass of the child. The mass is 25 kg. And the distance he climbed. The distance he climbed is simply the number of steps times the height of each step. The number of steps here are 20 steps times the height, which is 15 centimeters. And we are giving the time as 30 seconds. Then we are asked to calculate for his power. Now, we have to calculate for the total distance covered because he climbed 20 steps and each is 15 centimeters. So 20 times 15 becomes what? So you have 300 centimeters. But you remember that the standard unit for distance is meter and not what? Centimeter. So we have to convert from centimeter to meter. So in converting from centimeter to meter, what do?
We divide
by what? 100. By 100. Thank you very much. So we know that 100 centimeter makes 1 meter. So it becomes 300 centimeter divided by 100. That gives us 3 meters. So the total distance covered becomes what? 3 meters. Now quickly, power from our formula is work done over time taken. Now we have to calculate for work done, which is force times distance. Again, we are not giving force, so we'll calculate for force, which is what? Mass times acceleration due to gravity. That gives us 25 kg times 10 meters per second square, which is what?
250 Newton.
Alright. Now that we have a figure for force, now that we have calculated force, we can now calculate for work done. And work done becomes 250 Newton. What's our total distance?
3 meters.
So it becomes what?
750 Newton meter or joules.
Thank you very much. So we can now calculate for power since we have our work done. So power becomes 750 Newton meter all over 30 seconds. 0 cancels 0, that's 75 over 3. This becomes what? So from the calculation, 75 divided by 3 will give us 25. And you know that our SI unit for power is what? Newton meter
per second.
So
joules per second.
So the power of this student is simply 25 Newton meter per second or joules per second. I hope you've been able to learn how to calculate for work done and power, work done, power and force from this class today.
Yes, ma'am.
Salvation International Preparatory School. Salvation International